Welcome to this video, Trunking Basics for the Alaska Land Mobile Radio System. This video will review the concepts of digital trunking as it's specifically used for the ALMR system. ALMR is an APCO Project 25 digital trunked radio system. The Project 25 is a global standard for public safety and other types of radio systems that ensures maximum interoperability, security, and reliability. ALMR is one single system that consists of local, state, federal, nonprofit, and military agencies and entities that provide public safety functions. Although this radio system is one system, it is divided into several functional zones that is beyond the scope for this discussion. The zones are primarily for administrative and redundancy purposes. Traditional radio systems that do not use trunking technology generally use analog transmission and generally involve repeaters. Repeaters are tower sites that take an incoming signal, in this case an analog signal from a mobile or portable radio, and then rebroadcast it with higher power. This repeating or rebroadcasting allows for a radio to have significantly further range than a simplex configuration. Simplex simply means that there is no infrastructure involved in the radio transmission, and that the radio that you're transmitting on is being received directly by other radios that are listening on the same channel. ALMR uses similar repeaters that an analog transmission would. However, the system is completely digital, and it uses computer systems to direct traffic where there is a request for it. Looking at a traditional radio system visually, the mobile radios, such as a vehicle-mounted or a portable radio, transmit to the base station or repeater, and the base station then repeats that information back out to the radios in this two-way configuration. It uses a specific set of frequencies that are programmed in each radio to be able to accomplish this. Typically, radio systems like this are built to deal with terrain issues or issues in an urban environment, such as being able to penetrate buildings. The type of frequency and the type of equipment and location of the repeaters, either one or multiple, goes into the considerations for each specific area. This type of transmission is completely analog. This can be thought of as an old-style cell phone. You're transmitting analog voice similar to a radio station through the radios through the repeater, and then that analog voice is being repeated back out again. These traditional radio systems still exist, but there are a number of disadvantages to them, as well as some advantages over trunked systems. The main push for the traditional radio systems moving to trunked or digital capacity is the use of the radio spectrum, which we'll address in a moment. Unlike the traditional system we just viewed that may have one or more repeater sites, a trunking system, because of the digital technology, has a number of additional components. Controllers, databases, and other computer servers are located in what are referred to as master sites. These sites effectively function as the brains of the operation. All remote sites, or radio frequency sites, which we might use RF sites for short, are connected to the master site and to the main computer function. This can be thought of as a server room where each remote site is connected to it, and therefore each radio is controlled by the master site. The ALMR system has 3 master sites. In addition to the master site IT infrastructure, the transmitting and receiving equipment that is located at the various RF sites is more traditional radio equipment, which has antennas, combiners, repeaters, and other components that are designed to optimize the transmission of radio frequency energy. There is equipment in these sites that essentially transition between the IT network equipment and the radio equipment that the subscriber uses. Subscriber units are portable, mobile, aircraft, or base units that an individual member agency or user uses to interact with the system. All of this information or all of this infrastructure is controlled by the central master site and the databases and controllers there. The idea behind using this advanced technology is having the highest amount of optimization for the radio frequency spectrum, and also having a radio system that can function the way users and other needs are requiring of it. The primary difference between a trunked radio system like ALMR and the system we looked at previously is where the radio traffic is transmitted. In the conventional system we looked at, the repeaters, either one or multiple, rebroadcast all traffic that occurs on a channel to all sites. The ALMR system only transmits traffic to specific sites as it's requested. The ALMR system has well over 85 radio frequency sites that each individual radio can be affiliated to. Your radio, or subscriber unit, automatically affiliates to the best site, typically the site with the strongest radio signal between your location and the tower location. This may vary depending on the location and the location of the sites in your particular area. Some sites may be in cities, on towers, or on buildings. Other sites, such as those covering highway corridors, are often on mountaintops. When you're tuned to a specific talk group, the site that you're affiliated with knows that your radio is tuned to that talk group and will transmit the radio traffic coming over that talk group to your particular radio. However, if the site next to you does not have anybody tuned to that particular talk group, it will not transmit any of the information from the talk group to any radio. In other words, a radio has to be tuned or requesting that particular talk group or that particular channel in order to get the information. So when a subscriber unit broadcasts on a particular talk group to the tower they're affiliated with, that tower then assigns the radio a frequency and transmits out to each tower site where there's radio located or requesting it. It does not transmit to the tower site with no radio requesting that talk group. Another key difference with a trunked system is requesting a talk path, or requesting the ability for your radio to transmit on a particular talk group. Let's look a bit more closely at the first step that occurred in the previous graphic. When a subscriber unit user wants to talk on a particular talk group, they're going to depress their push to talk button. The request is sent to the site that your radio is affiliated to through something called a control channel. This is a channel that directs all of the traffic in that particular site. If there's available capacity on the site, in other words, there is a repeater or radio frequency available to that site for you to talk on, the control channel assigns that frequency to the radio and then allows you to transmit. The radio then turns the frequency, transmits that, and it goes into the system and goes out to any particular radio site and any radio that's tuned to that talk group. That is why with a trunked system, it may take a second or two to hear a chirp, which is called a talk permit tone, as the radio site allocates a channel to you. If there's no available talk path or no available channel, you may receive a denial tone, or what we call a busy. This is often referred to as a bonk for the way your radio tells you that you don't have an available talk path. When you don't have an available path, release the button, wait a few seconds, depress your push to talk button again, and try again. Sometimes it's difficult to tell the difference between a busy site and a site that you can't reach because of your particular location. If you continuously cannot reach a particular site, if you continuously reach a denial tone, try to move to another location. This trunking technology really makes a more efficient use of the available radio spectrum. Users have been putting increased demand on the available radio spectrum, This comes from the increased use of mobile phones and data services, and also technologies like wireless internet and many others. When radio systems were first developed, the radio spectrum was relatively less encumbered at the time, and each radio user or each radio system was assigned essentially more of the radio spectrum. In 2012, a mandate was put into place that the less space in the radio spectrum be used for public safety communications. This was called narrowbanding. This was one of the first steps to essentially compress the use of the radio spectrum down with increased technology to be able to allow more users, again, like cell phone companies, mobile or wireless internet service providers, etc. So by being able to trunk the radio frequency and be able to essentially serve things on demand, significantly less radio channels, actual frequency is required at each site to be able to actually use much more efficient ways to use the spectrum. So that's a tremendous advantage from a system standpoint, being able to serve more and more users with the same amount of radio spectrum. At the same time, a system like ALMR, by having these multiple RF sites, so our 85 RF sites stretch from north of Fairbanks down to southeast Alaska, if we have to extend the area for a particular talk group, particular operations if necessary, we can easily do that. For instance, if there was an operation going on in southeast Alaska for the troopers, there is the ability, if needed, for the headquarters in Anchorage to monitor that radio traffic live because the system is linked. The digital transmission allows for compression of audio, and this is another advantage that ties directly back to more efficient use of the radio spectrum. At the time of this recording, the ALMR system is transitioning to a technology called TDMA Phase 2. When that is complete, that is going to allow essentially two radio transmissions to occur at the same time in the same frequency. Again, essentially doubling the capacity of the system, but using the same amount of radio frequency spectrum. Radio spectrum is an important component of the system because it's increasingly difficult, even for public safety agencies within Alaska, to be able to obtain licenses for additional radio spectrum. It tends to be a very arduous process with significant justification required to be able to get additional licenses. So being able to use the license components that we have, the radio spectrum that we currently have, is the advantage to this. There are some additional technologies that the system allows us to do. Security is higher. Instead of an analog analog transmission like we looked at in our first slide, a digital transmission is much harder to scan and much harder to decode from somebody listening without specialized equipment. And it does allow us to use advanced features like encryption to further secure that traffic even more. As we look at advances in the system and upgrades that are taking place, it allows us to do things like being able to remotely control radios that may be lost or stolen, provide a location of a first responder when they talk, and many other functions really still being tested. If you used old-style conventional radio, there are a few key differences between the digital trunking system and that conventional radio that we've touched on. However, because the system is now digital and the transmissions are digital, instead of hearing transmissions that are staticky that you may be able to make out some piece of it, transmissions are generally now all or nothing. Either the radio is in range, it's a binary component, the radio is in range, or it's not. So that's a key difference that's important when you're in an area that doesn't have strong radio coverage. Additionally, scanning functions may not work as expected or may not work at all. Scanning in old-style radios was dependent on the radio cycling through different frequencies, and because that information, that traffic was broadcast out in the way that it was through all of the repeaters or all of the antennas, it was fairly easy for a radio to be able to scan multiple transmissions. That does not work in the same way for ALMR, and scanning is not recommended to be enabled in any radio on the ALMR system, as it can cause additional load on the system and reduce capacity. There's a high-tech radio network using generally microwave and some fiber optic cable that links all of the radio frequency sites together, known as SATS, the State of Alaska Telecommunications Service. That's the data network that allows the ALMR system to work properly and for all of these components that we've described to happen in just less than a second in most cases. However, if a site loses communication, there is a mode called site trunking, which does not allow the radio to go into that wider area we've talked about, but allows it to remain on that specific RF site that it's affiliated with. That is something to be aware of, and also to be aware of how your subscriber unit displays that alert if that were to happen. There is another video on the ALMR website that goes into more detail about site versus wide trunking. This program is part of a larger training program available of short videos and live presentations that are available at alaskalandmobileradio.org. If you have any questions about the system or any technical issues, please contact the ALMR Help Desk or the ALMR Operations Management Office.